Hey everyone, I have received a couple of questions on how to draw angles in radians. So I wanted to give you a brief video on working with radians as far as positioning of an angle and working with those fractions. So this is from section 6.1 and this is my problem number 7, and it says to draw the angle -7 pi over 6 in radians and standard position. So this is based on the quadrant angles. So if I were to draw an axis, and we're working here, remember standard position means that we begin with our initial side on the x-axis, and then if it's a positive angle, then it opens this way, negative angle opens this way. So some of the quadrant angles, if you're talking about one that is in the initial position and goes to this 90-degree mark, that is our pi over 2. If you're in the initial position and you go to the 180-degree mark, that angle is pi. If you are working to the 270-degree, that one is 3 pi over 2. And then all the way around, if you get all the way back to the 0 mark, the 360-degree is 2 pi. So remember that negative means that you're opening clockwise instead of counterclockwise. If I am working with fractions, then we're talking about making some fractional equivalencies. So for example, this one is in sixths. Now, if I'm working with sixths, then my initial position is still 0. So here is my initial position. I'm going in the reverse direction. If I were to come all the way over to here in the negative direction, that's pi. So pi would be 6 pi over 6. Because we have 1 there. Now if I were to go to here in the negative direction, remember we're negative, if I were to go to just here in the negative direction, then that one means that I'm moving pi over 2. 1/2 in 6 would be 3 pi over 6 going in the negative direction. Positive direction, same thing, just positive. So if I were to try and draw this angle, this one that I'm looking for, the problem that I have says -7 pi over 6. Well, 7 pi over 6 is a little more than 1 pi, so I'm a little more than the 180-degree mark, which is pi. So I'm moving in the negative direction. This would be 6 pi over 6. I'm going to go a little bit further than that to -7 pi over 6. So I'm looking for an angle that looks somewhat like that. So -7 pi over 6. If it were +7 pi over 6, I would end up right about here. So I'm going the same distance, just in the positive direction instead. All right, looking at these, looks like D is the winner. Excellent. Next question. All right, so this asked me for 4 pi radians in the standard position. So remember, if we went all the way around, we get to 2 pi. If I were to continue counting pi, then I would count 3 pi and then 4 pi. So we're looking for one that goes around 2 full revolutions of the circle. And looks like A is the one that goes around 2 full revolutions of the circle here. Now, instead of answering this one, I am going to try and I'm going to get this one wrong a few times and see if I can get a different number. Similar question. All right, here's another one where it says that I want 13 pi over 4 in radians. All right, so when we're talking about fourths in pi, remember that if you are working with fractions, then we're starting in the initial position. We'll use pink this time. Here is our initial position, and what we're looking for is 13 pi over 4. Now if I went to the 180 degree mark, pi is equal to 4 pi over 4. So I'm going to count these until we get too high, or not high, just barely not high enough, and then we'll look for the extra pieces. So moving around, here we have 4 pi over 4, so that's 1 pi. If I were to continue on, when we get back to the original location, we're at 8 pi over 4. So 4 pi over 4, 8 pi over 4. Continue moving on, if we add another 4, we're at 12 pi over 4. Now what I'm looking for is 13 pi over 4, so I'm going to continue just another little bit, and we get 13 pi over 4. Alright, so I'm looking for one that goes through one full revolution and then another little bit more than half. So looking at my diagrams here, this one goes too far, so I'm going around to here, and that's not where I want to end up. This one, I also don't want to end up in the first quadrant. This one's in the third quadrant, but quarters means that I need to be equally distant between the 180 degree mark and the 270 degree. So this isn't the one I want, which leaves me with A. Goes around one full revolution, stops 3/4 of the way, and that is the one we're looking for. All right, if you have any further questions, please let me know, and I will see you again soon.